Okay guys, so this is the second video for this week. We're doing notes 2.2. Today we're going to be converting rectangular and polar equations. So here's the definition. It didn't come out very well, so I'm going to give it to you. You replace x with r cosine theta. Vice versa, you can replace r cosine theta with x. And you replace y with r sine theta. Okay? So let's look at this first example. Find the rectangular equation corresponding to the polar equation r equals -5 over sine theta. Okay? Well, we need one of these. We need either an x or a y. There's no x and y here. Okay? We need an r cosine theta. I don't see an r cosine theta anywhere in there. Or we need a sine theta. Well, here's a sine theta. We don't have an r sine theta though, but if we just multiply both sides of the equation by sine theta, these will cancel, and now I have r sine theta equals -5. And so now I can replace this r sine theta with y. So this whole thing becomes y equals -5. And we're done. Okay? So not too bad. Alright? You just have to see what you want to do. In this case, we were converting polar to rectangular. So we knew we had to find r sine theta or r cosine theta. Okay? I'm just going to leave that up. Okay. So the next one says convert a rectangular equation y equals x squared into polar. Well, now we're just going to replace all our y's with r sine thetas and all our x's with r cosine theta. So this becomes r sine theta equals r cosine theta all squared. Okay? So then now you just square this side. So r sine theta equals r squared cosine squared theta. Okay, divide by cosine theta on both sides. And then divide by r. And you end up with sine theta over cosine squared theta equals r. Okay? So again, what I did, I squared both of these, r squared cosine squared, that gets rid of the square there. Okay? I divided by cosine squared, because I'm trying to get r by itself. So I divide by cosine squared. Okay? And then I divide by r, and that cancels that square, and you end up with just one r right there. Okay? Okay, so I believe I gave you this already. So x squared plus y squared equals r squared is the equation in rectangular form of a circle with radius r. Well, if you look at the second equation, it says, hey, the radius is 2. So it's a polar equation with the radius of 2. So we just need to convert to x squared plus y squared because that's the rectangular equation for a radius of 2. So here we have, okay, x squared plus y squared equals r squared. So then x squared plus y squared equals 4. And we're done. Okay, easy enough. Alright? So, you come back over here. Leave that up there in case I need to reference it. Alright, so the last example, convert x equals 1 to polar form. So, we need to go and get this into polar form. Well, if x is 1, then we know what x is. X is r cosine theta. So r cosine theta is 1. Okay? And the polar equations, we always want r to equal something. So if we want r to equal something, we just divide by cosine theta. Okay? And so now we're done. You could, I prefer not to go to secants and cosecants and cotangents because we really like sines and cosines and tangents in the higher level maths. But if you do want to, you guys should all remember what 1 over cosine is. In trig, 1 over cosine is secant. And you're done. Okay? So, not too bad. Okay, so converting rectangular points to polar points, we kind of covered this in the last video. Alright? But the only difference here is now we're going to polar instead of rectangular. Okay? But the r is still going to be the square root of x squared plus y squared. That comes from Pythagoras. Alright? So the only difference here is that before we were using sine and cosine to define y and x. Now we're trying to find theta, and it's easier just to use tangent and y and x. So that's what we'll be doing. Okay, so here it says convert the rectangular point to the polar point. Okay, so if we have 1 comma negative 1, if you look at the graph, 1 negative 1 is right here. Okay? And we need to convert this to polar. Okay? So we know that our x is 1, our y is negative 1. So what the easy one to get right away is r. So that's the square root of 1 squared plus 1 squared. So then you get root 2. So r is root 2. Okay? And then to find our theta, so theta, or the tangent of theta, is y over x. That's right on the notes. Right here. Tangent of theta is y over x. Okay? So then the tangent of theta is negative 1 over 1. And so if you remember from trig, negative 1 over 1 is just negative 1. Okay? And if you remember from trig, if you have the tangent of an angle equals to something, then the angle is the tan inverse of that something. Okay? And if you do the tan inverse of negative 1, you're going to get negative pi over 4. Okay? Now, if you think about the unit circle, because on the notes it says 7 pi over 4. Well, wait a minute. You said it was negative pi over 4. Well, if you look at this guy, if you go from here all the way around the unit circle to here, you've traveled 7 pi over 4. But if you just go from here to here, you've traveled negative pi over 4. Remember, they're the same angle. It doesn't matter which one you put. It both work, okay? I just like this one because it's easier for me to see it. But you do whatever works for you. If you put this in the calculator, it's going to give you that one. So you better make sure you know which one you're using. Okay? All right, let's look at the next one. Three, 3. All right, we look at the graph. 3, 3 is right here. Okay? So then, if we draw our triangle, this is 3, and r is the square root of 3 squared plus 3 squared, which is the square root of 18. Okay? And so now you just need to do your theta. So theta, the tangent of theta, is y over x. And in this case, that's 3 over 3, which is 1. So then if the tangent of theta is 1, then theta is the tan inverse of 1. And this is pi over 4. Okay? So then your r theta is root 18 comma pi over 4. Okay? Pretty simple, guys. Not too bad. There's a couple more examples here. I'm not going to go through them. You guys can look at them if you need to. And then, like I said, if you have any questions, please see me in tutorials. And I'll see y'all next time.